Hey everybody, this is Larry. This is day 2 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 1601, maximum number of achievable transfer requests. Yeah, so this one, it's a little bit memorable for me. I think I kind of talked about it just yesterday because I got a little confused with the premium weekly problem. And this is meaningful to me in a way because this is the Q4 of one of the contests that I won. And when I say I won, I mean I finished first in that contest. I don't remember when that was. Let's see. So that was in what's that? Wow, that was almost 3 years ago. But still, so I guess that is a little bit memorable. But I mostly remember this drawing and stuff like this. And you if you kind of search for it, or maybe I'll put in the comments or something. You could see my reaction and how I did this one. But let me actually kind of refresh my memory. I don't actually remember, this particular. Oh, I don't remember. Let's see. Right. So okay. So you have n buildings. You and transfer, you're given request. All the buildings are full, so the net change of 0.0. That means return the number of maximum achievable request. Okay, so I think and the key thing to note is that request length is only 16, and because of that, that means that you can actually brute force on the request. It is probably one of those NP plus problems, so it probably is the best you can do, and in that way, I mean, I think there isn't. I was going to say maybe there's some dynamic programming, but you don't really have to even, right? Because you only have 16 requests. I mean, I guess you can in some subset way, and maybe that's slightly faster in that you do build up smaller subsets to bigger subsets, maybe, but you don't even need to do that because there's only 16 requests. So 2 to the 16 times 16, which is like an n times 2 to the n algorithm, should be fast enough. So let's do it. And I say n, when I say n, I mean the number of requests. I don't actually even know what this n is. The number of buildings. Okay, but that doesn't even matter, to be honest, right? So yeah, okay. So so we can just kind of let's just say R is equal to request, right? So then you could do it in a couple of ways. I think I'm going to do recursive today, but it is still, like I said, just literal. Brute force, right? Just for every request, see if we want to do it. So so let's just say naming things is kind of the hard part, but I'm just going to call it calculate. I'm a little bit lazy today. Index for the subset, and and then we calculate for 0, and then we return the best, right? So then now if index is equal to R, we do something with the best. So best right now is 0. So then now we have maybe a net type thing. Net as in maybe just a lookup. I don't know. Doesn't even matter. Or like a net transfer per building is what this means. But yeah. So if if or x is equal to 0 for x in net, then best I think maybe I'll just keep a count thing here. Best is equal to max best count. I mean, this is going to be all like pure brute force recursion, right? So it's a little bit yucky maybe, but yeah. So but basically, and like we said, we just process this request, or we don't process this request, right? So now we process this request. So we this is saying that we do want this request. So then here, or maybe we start with we don't want this request first. Maybe that's easier, right? So we calculate index plus 1, and then count just stays the same, and then that's it, right? Otherwise, if we want this request, then we have to do net of what is so from to okay fine ft is equal to request of index. So then now the from we move 1 t plus 1, right? And that's pretty much it. I mean, of course you have to undo the thing for backtracking, but that's pretty much it, I think, right? Yeah, it looks okay. Let's give it a submit. Yeah, I mean, I think this is a little bit fast on the video, but the reason why that is because because it is just brute force. You can see it, right? Like we just basically, for every request, we don't want it and we want it, and we calculate what happens for both. This is right now 2 to the n times n. Because of this is n over n. Maybe you could do some amortized thing so that it becomes just 2 to the n. And you could do that by just keeping track of number of zeros and stuff like this. It's more bookkeeping, more complicated, but not that much harder, to be frank. But yeah, I think I did it a different way during the contest. So if you want to check that video, yeah, I did it with Bitmask, and also pretty short, to be frank. And so yeah, and this is the problem that I won the contest with. I mean, you know, there are other problems on the contest. You could check that out. I want to say that I think there was like a Q3 that was hard to read or something like this, which is why I won it. But it's not just this, but usually Q4 is my how I lose it. So yeah. Anyway, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great weekend. I'll see y'all soon. Bye bye.